Hey everyone, ready for a deep dive into something that can seriously shake up medicine? We're talking virtual clinical trials.
Sounds pretty futuristic, right?
It is. Imagine testing new treatments without risking real patients and getting results way faster.
That's the idea.
That's what we're breaking down today. We're looking at a research paper titled Virtual Lung Screening Trial, VLST for short.
Catchy.
It is. It's all about recreating a big lung cancer screening trial. But get this, in a completely digital world.
Like the Matrix for medicine.
Kind of. They use virtual patients, virtual scanners, even virtual radiologists,
Right.
all powered by AI.
Yep, and it's pretty remarkable what they pulled off.
So break it down for us. What exactly is a virtual imaging trial, a VIT?
Think of it like a digital twin for a real clinical trial. Instead of recruiting thousands of people, they create a virtual population with all sorts of characteristics, ages, sexes, races, even different types of lung nodules.
So it's like they built a mini world inside a computer, but like with all the complexities of human biology.
That's a good way to put it.
I'm already hooked. Tell me about these virtual patients. How do they make them?
It's pretty wild, the level of detail. They use this model called XTAT that simulates human anatomy down to the tiniest bits, like we're talking bones, organs, tissues, everything. And they can tweak each virtual patient, give them specific traits like age, smoking history, or lung conditions.
So they're not just cookie-cutter copies, they're unique.
Exactly.
Wow, okay, so they've got these virtual people. What's next?
Well, you got to scan them, just like a normal trial. That's where the virtual scanners come in.
They thought of everything.
Pretty much.
Yeah.
They use a program called DukeSim. It can indicate different types of scanners and conditions, even different brands and models of CT scanners, because, real scanners produce slightly different images.
Well, hold on. They're simulating the machines, too.
Yep. Got to be thorough.
Mind-blowing. So who's reading these virtual scans?
AI takes the lead there. They trained these models, called RetinaNet, on tons of real chest x-rays and CT scans.
So like a robot radiologist.
You could say that. These AI readers are super accurate at spotting lung nodules, just like a human radiologist would.
That's wild. But why go through all this virtual stuff? What's the point?
Well, think about traditional clinical trials. They're slow and expensive. You need tons of participants, got to track them for ages, and then there's mountains of data to analyze.
Yeah, and by the time you're done, the technology could be obsolete.
Exactly. Plus, there's the ethical side. You're testing new treatments on real people. There's risk.
Okay, so with VITs, no risk to patients. Got it.
Well, speed. You can run these trials way faster. No waiting for recruitment or data collection.
So faster, cheaper, safer. VITs sound like a win-win-win.
They have huge potential.
But how do we know the results are accurate? Like, do they match up with the real world?
That's the key question, right? They wanted to see if they could replicate a huge real-world study using this virtual setup.
Okay, so what study did they pick?
The National Lung Screening Trial, the NLST. It's a landmark study from the early 2000s. It involved over 53,000 people. And it proved that CT scans are effective for lung cancer screening.
So that's the gold standard.
It is. They wanted to see if their virtual trial could recreate its findings.
Interesting. What happened?
The results were pretty much identical. Just like the NLST, the virtual trial showed that CT scans were much better than chest x-rays at detecting lung nodules, those little spots that can be an early sign of lung cancer.
So CT scans win again.
Yes. Early detection is key with cancer, right?
Absolutely. But how did they measure this better? Like, how accurate were the scans?
They use something called AUC. It's like a score. Higher score means better accuracy.
Okay. So what were the scores?
CT scans in the virtual trial got a 0.92. Chest x-rays only got a 0.72.
Whoa, that's a big difference.
It is, and here's where it gets cool. The virtual trial could even see differences in how CT scans perform depending on the type of nodule. Like, they were even better at picking up homogeneous nodules compared to heterogeneous ones.
Wait, so not all nodules are the same? And the virtual trial could tell the difference?
Yep, pretty impressive, right?
Super impressive. Okay, so this was just one study focused on lung cancer. What's the bigger picture? Does this mean we can use virtual trials for, like, everything?
This study is like a proof of concept. It shows that VITs could change the way we do medical research for lots of conditions.
Okay, so paint me a picture of the future. What could this lead to?
Imagine developing new treatments in a fraction of the time, and all in a safe, virtual space.
Okay, I like where this is going.
And it's not just about speed. Think about testing new treatments on virtual patients with specific genes or conditions. You could tailor treatments to individual needs in a way that's impossible with normal trials.
So super personalized medicine.
Exactly.
That's amazing. But we need to unpack all this. There's so many questions to explore. Okay, so we've seen that virtual trials could speed things up, personalize treatments, and maybe even make trials safer. It's pretty
Yeah.
mind-blowing. But are there any, downsides? What could go wrong?
It's good to be cautious. VITs are new, and like any new tech, they've got their own quirks and limits.
Okay, I'm listening.
Well, for one, the virtual patients, even though they're diverse, there aren't as many of them compared to a big real-world trial. This study only used 294 virtual patients. That's nothing compared to the 50,000 plus people in the original NLST.
Yeah, I guess making and simulating thousands of those virtual patients would take a ton of computer power.
Exactly. It's like building a digital city.
Crazy.
What else? Another thing is they only used one AI model for each type of scan, so they couldn't really account for all the differences you'd see with, different human radiologists reading the images.
So they're kind of assuming all radiologists are the same, which isn't true at all.
Exactly. Everyone's got their own experience and ways of seeing things.
Right.
And they know that's a limitation. They want to fix that in the future by using multiple AI models, with different levels of experience.
Makes sense. You got to capture all those different ways humans interpret images, especially in medicine.
For sure. What else? Oh, this study only looked at whether the AI could detect lung nodules. They didn't look at what happened to the patients after that.
Like if they actually got lung cancer or how they responded to treatment.
Right. They basically had pause after the scans were analyzed. It would be super cool to see those virtual patients over time. Do their tumors grow? Do they get better with virtual treatment?
Like a medical soap opera in the digital world. I love it.
Uh-huh, yeah. And you're right. Seeing long-term outcomes would be super valuable. But that's way more complex. Remember, the real NLST tracked patients for years? It'll be interesting to see if virtual trials can do that too someday.
So huge potential, but still early days. It's like we've opened this door to a whole new world of research, but we're just starting to figure it out.
A good analogy. This study is like a sneak peek into what healthcare could be: faster research, personalized treatments, and maybe even lower costs. But VITs aren't meant to completely replace real trials just yet.
I was just thinking about that.
Yeah.
Are these two approaches like rivals, or do they work together?
I see them working together. VITs are great for screening potential treatments, testing new imaging tech, and even planning better clinical trials. But for now, real-world trials are still crucial. We need them to confirm findings, check long-term safety, and actually get new treatments to patients.
So it's not about replacing humans with machines. It's about using tech to make us better, like giving researchers a new tool, but they still need their skills and judgment.
Exactly. VITs can help us ask better questions, come up with ideas, and make smarter choices about what to test in those real-world trials. Basically make us more efficient, more precise, and more successful at improving health.
Love it. Okay, let's zoom back in to lung cancer screening. What does all this mean for someone who's deciding whether or not to get screened?
This virtual trial basically confirms what we learned from the real NLST. CT scans are way better than chest x-rays for finding lung nodules, those tiny spots that could be early cancer. And their CT results were almost exactly as good as the original study.
That's amazing. So if someone's eligible for screening based on their age, smoking, and all that, they should go for the CT scan.
Well, that's a talk they should have with their doctor. Everyone's different. But this research definitely shows that CT scans are the best tool for early detection. And that's huge for fighting lung cancer.
And the fact that this virtual trial basically mirrored a huge real-world trial is just, wow. It shows how powerful this approach could be.
For sure. And this was just one study on one type of cancer. Imagine using this tech for all sorts of medical problems. We've barely scratched the surface.
Okay, so we've talked about what virtual imaging trials are, how they work, and why they're a big deal. We've looked at the good and the bad and what they could mean for lung cancer screening. But what about the future? Where do we go from here? So much to think about, but where do we go from here? What's next for this whole virtual trial thing?
Well, if this lung cancer study is anything to go by, the future of medical research is looking pretty virtual. We could use VITs for all kinds of conditions, not just lung cancer.
Like heart disease,
Oh,
Alzheimer's, even stuff like Zika.
you got it. And we're not just talking about copying old trials. We could use VITs to test out completely new imaging techniques or treatments, like try out risky stuff without putting real people in danger.
That makes sense. So what else?
Imagine personalizing treatments, like using someone's virtual twin to create a treatment plan just for them based on their genes or their specific disease.
Wow, that's the next level personalized medicine.
It is. And think about rare diseases. They often don't get a lot of research attention, right? But with virtual trials, you could make as many virtual patients as you need, all with that specific rare disease. That could really change things for people who don't have a lot of treatment options.
Totally. And we can't forget about cost. Could VITs make healthcare cheaper?
Definitely possible. They could help make research faster and cut down on those expensive, long clinical trials. And if we find better treatments earlier, that could save money in the long run.
It all sounds pretty amazing. But let's be real, there are still challenges, right? We talked about the limits of the tech itself. But what about bigger concerns? Like, are there any risks we need to watch out for?
You're right to ask that. Any new tech has potential downsides. One thing that comes up a lot is, like, are we going to rely too much on AI? We got to remember, these AI models are tools. We need to use them carefully.
Well, it's not about just letting the algorithms decide everything. We still need human doctors and scientists to, make sense of the results and treat patients.
Exactly. AI can't replace human expertise. It's more about giving doctors and researchers new tools. Tools to make better decisions, diagnose things earlier, and create better treatments.
Okay, makes sense. It's all about finding that balance. Using tech to boost human intelligence, not replace it.
Exactly. And we've got to be careful about the data these AI models learn from. If the data is biased or incomplete, the results could be wrong or even dangerous.
Garbage in, garbage out. We need good data to train these AIs. Diverse, representative, high-quality data.
You got it. Data quality is key. And then there's data privacy, too. These virtual trials use super sensitive medical info. We got to keep that safe.
It seems like we're at the beginning of a huge change in how we do medical research. But we need to move forward carefully and thoughtfully.
Definitely. This tech could make healthcare better for everyone, but we've got to be aware of the risks and work hard to avoid them.
Well, that was a deep dive. We explored this whole world of virtual image of trials, from the nuts and bolts to the big picture. It's exciting stuff, and I hope everyone listening is as pumped about the possibilities as I am.
Me too. It's a really cool time to be working in this field. Everything's moving so fast, and I can't wait to see what the next few years bring.
Before we go, I want to leave everyone with a few things to think about. What if virtual trials keep getting better and better? Could they actually replace real-world trials someday? What other areas of medicine could use this tech? And how do we make sure these tools are used ethically and responsibly?
Those are great questions. And they're not just for scientists and doctors. Everyone needs to be part of this conversation. Policymakers, ethicists, regular people. It's about how we shape the future of healthcare.
Exactly. So keep learning, keep asking questions, and keep talking about this stuff. And if you want to dive deeper into this specific study, you can find a link to the research paper in our show notes.
Thanks for having me. This was a great discussion.
Thanks for joining us, everyone. We'll be back next week with another deep dive. Make sure you subscribe and tune in.